I'm Scott Wade, and I'm studying mechanical engineering here at BU. I'm here to present to you energy-efficient vertical farming with autonomous harvesting. First, I'd like to give credit to my advisor, Dr. Anthony Lin, and my 4 teammates, Devin Goodwin, Daniel Vinals, Aman Patel, and Peter Quiros, who unfortunately can't present today. So, the issue that we're tackling is the issue of unsustainable agriculture in the American West. In the American West, it's a very arid and often high-altitude environment, so agriculture can be done with dubious validity. If we can look at this picture over to the right, this is an example of a farm pretty close to where I grew up in Nevada. In this farm, we use large sprinklers such as this to draw big circular areas and sprinkle over the ground, creating this huge discrepancy between the farmed areas and the arid land around it. This type of farming puts a lot of pressure on water supplies in the area, and it's resulted in a constantly depleting groundwater in the area, which threatens the future of agriculture in the area and also the future of human development. So one solution to this is the method of vertical farming, where by moving plants to an indoors climate-controlled environment, we can save a lot of water and a lot of energy from being used. Well, not so much energy as we'll find out, but we can save a lot of we can save a lot of water use because it's a climate-controlled indoors environment where there's not as much evaporation out to the outside environment, and there's not so much drainage into the dry soil. In addition, we can grow plants at the ideal conditions by controlling their temperature and humidity, and we don't need to worry so much about outside pests. Finally, in a controlled environment like this, a lot of the light is provided by artificial lights, which allow you to increase the length of a day to increase the yield of the plants. However, there are a couple of really big limitations to vertical farming that prevent it from being widely adopted now. Those 2 limitations are the high energy use, which is largely driven by the climate control. It takes a lot of energy to take this big space full of plants and to completely air condition the entire space. And then you have to replace the energy from the sun with the lighting. So that's one of the big issues, is that this high energy use actually makes it so that while vertical farming saves a lot of water strain, it actually adds a lot of carbon footprint to it, making it slightly worse than traditional farming in that sense. The other bigger issue, which our project largely tackles, is the issue of the available plants which are able to be vertically farmed. Currently, there are a lot of issues with harvesting and long-term plant growth that prevent vertical farming systems from tackling plants such as berries and nuts and other high-value stuff. Typically, these systems will work on leafy greens such as your lettuces and your kales, and the way that it is done is they have a warehouse where flats of plants are grown, and in these flats of plants, they'll wait until the plants are fully mature and then use forklifts or some other conveyance technology to move them to a separate harvesting area where people will actually manually harvest the plants. We wanted to address this limitation with a system that will allow plants to be continuously harvested over their growing space so that things that ripen over a different amount of time can be harvested. And we also wanted that to be done in the growing space, so that we don't waste a lot of energy moving plants and all of the associated infrastructure around a warehouse. So to do this, we wanted to capitalize on a fruit that benefits from being continuously harvested, and we wanted to develop a physical prototype of a robot that could harvest these plants. What we decided to focus on was the day-neutral strawberry. This is a variant of strawberry that has to be harvested every 3 days or so because it's very, very variant on how quickly they ripen. Typically, you'll look at a plant and like half of them will be unripe and some of them might ripen in the next couple days. So you really have to continuously use a robot to do this. In addition, you can look at the architecture. It's very, very accessible for a robot to come in and pick these. So that's what we decided to focus on with our design of a robot to harvest them. In this robot, we are using a computer vision system to detect the berries that are ripe and the berries that are unripe. And then the robot will traverse down the set of troughs and use a robotic arm to pick the berries. We've also done a study showing that the system can be scaled by vertically stacking the troughs to adapt it to a vertical farming situation. Our physical prototype includes a robotic arm, as you can see in the top left, and the robotic arm has a camera on it, which is a binocular camera system that can detect strawberries in 3 dimensions. Then we use a horizontal movement system, as you can see in the bottom left, to move it towards the berry. And finally, the robot arm uses a spinning blade with a claw in the top right, to pick the berry. So this has taken a lot of engineering effort, and I'd like to show you a couple things that the system is capable of. Well, you might have to just imagine really well this video playing on the right. But we have gotten it to the point where you can very effectively use the blade to cut through simulation berries, and you can collect them very effectively into the basket. And we have also gotten to the point where our vision system is very effective at detecting where the berries are in 3 dimensions. We're using a color thresholding system to make sure that we only detect ripe berries. Then the robot arm attempts to move to where the berries are, and what we're currently working on is getting it to actually go to where the berry is, because right now it gets close. It gets about an inch within where the berry is, which, since strawberries are only about an inch big, entirely misses the berry. But all hope is not lost. We're working very, very hard to get this done over the next week, because we have until next week to finish this project. So for our final results, we have designed a system that improves the spatial efficiency because you don't have to have a separate harvesting area. And the system can be effectively used on a new crop, which isn't currently done in vertical farming. Finally, we have created a prototype which checked almost all of the boxes that we developed, except for just the last one, which is the inverse kinematics of the arm, is what we're working on fine-tuning to make sure that it actually goes where it wants to go. Any questions?
So really cool project. I'm curious, so it seems like this example you've chosen to test on with the strawberries is great for the computer vision because the bright red stands out so clearly against the green background. Would your system be able to work on plants that maybe aren't as easily discernible from like the leaves they're growing in or that sort of thing? Or do you have like other ideas in mind for how you maybe supplement computer vision to improve that sort of technique?
Yeah, good question. So there's a few different technologies that are used for computer vision in this sort of application. And because we have a lot of different moving pieces in our project, we wanted to pick the simplest one and then maybe upgrade later. So we actually chose hardware, which is capable of running more advanced neural network-based detection approaches, which work a lot better on things that aren't just color-based. So right now, what we have implemented is just color-based, but we've actually done extensive research, and we had chosen something that we could have implemented to make it work on things that aren't just red, which is a neural network-based edge detection method. But that's not what's currently implemented. So there's room for that in the future, and it wouldn't take that much longer, but not currently in the system. Thank you.
Really nice talk, Scott. I think it's a cool idea in general, and I was wondering, what's the history of these particular berries? Did somebody else, not necessarily genetically engineer them, but select for this property of rapid turnover before? Are there other crops like that? And I mean, I realize that's background, but I'm just curious.
Yeah, that's a good question. I know that there's a lot of different variants of strawberries, and most of them are a little bit more, I guess, ripening all at once than this one. But this one, I think, was developed to have the highest possible yield. I forget which university did it, but I think there was a university that developed this strain.
Great presentation, Scott. I know you talked a bit about the kinematics at this stage of prototyping aren't where you want them. I guess how did the performance of the computer vision system go, and could you talk a bit about that?
Yeah, the computer vision system performed very well. It has a little bit of issues right now with detecting if there's a clump of berries together. It might see it as one big berry instead of little ones, but it actually it went surprisingly well, and I don't think it should have gone as well as it did, but we were able to detect berries very, very consistently, and we get a very accurate depth reading as well.
This is really super cool, and the engineering and the robotic aspects of this are, I can imagine all kinds of extended applications for that. But what I actually want to ask you about is the agriculture part of it, and particularly the culture part of the agriculture. So often we think about agriculture as actually embedded in human systems, human social and kind of cultural, even moral systems. I'm wondering whether you've thought about those components. This might not be your wheelhouse, but whether you've thought about that in terms of moving agriculture to what seems like a completely human-free kind of zone. And what implications does that have? And whether this is really just about a commercial use, or whether you see this then being sort of re-embedded into other places where agriculture has traditionally been part of human and social systems.
Oh gosh, that's a great question, and I think that's also a really interesting question. you're right in saying that I definitely don't have as much expertise in thinking about that, but I do think it's really interesting to think about the future of agriculture and how that might adapt as technology is increasingly adopted in it. But yeah, thank you for the question.
This is kind of a similar question, but more focused on climate and economy. So would you imagine a system like this in other contexts beyond Nevada and in other climates? Would it be economically feasible? Like, is this, I guess, a solution to hunger globally?
Good question. I think that when it comes to agriculture, it's very region dependent because, like, obviously the climate affects the way that crops grow a lot. Vertical farming's especially useful for places with water scarcity, but like I mentioned before, the energy use makes it so that it's maybe not something that you would want in a place that has a lot of access to water. I think that it could be useful in a lot of places, though, especially because there's a lot of issues coming up with increasing drought frequency due to climate change.
First of all, fantastic presentation. I had a question, weirdly enough, if you researched about this, I'm so sorry if it's like not your wheelhouse again, but about like the shipping industry. I think during the pandemic, there were a couple of shipping industry holdups, I guess I would say, and a lot of shortages. And if we have these sort of indoor vertical agriculture and it happens widespread, do you imagine that, one, it would decrease the need to put a strain on our shipping industry around like the global shipping industry, not just America, because we wouldn't have to, I guess, wait to pick things or like pick things unripened and then try to ship it as far as we could, and we could just grow it in, home states, home countries. So do you think that would like lighten the burden on shipping industry? And then on top of that, in your blurb, I think in one of the first couple of slides, you said this is a very high energy cost system. Was that figure, did you include any of like the shipping industry, like lightening of burdens? I'm sorry, I'm not like saying this correctly, but did you include like a figure of how it would decrease the burden on shipping industry? Like, was that still like in that climate change, high cost energy figure that you were talking about?
Yeah, that's a great question, and that's something that a lot of studies that I looked at while I was researching this did address, actually. It's interesting because you can imagine that vertical farms could be put anywhere and thus reduce the reliance on shipping and thus reduce the climate footprint that happens as a result of shipping things. However, even accounting for that, it is still energy intensive, and analyses were not entirely agreed on about whether these systems would end up being moved to closer areas. Especially in urban environments, the cost of real estate becomes a significant barrier to entry for these systems, so it's likely that they would still be in somewhat suburban or rural areas. All set? Okay, thank you.